This guy. Okay. You guys in the back can see it?
Yep.
Can you see the gray?
Yep, July 23rd.
Can you read the Twitter handle at the bottom?
No.
That's a URL, not Twitter handle. Okay.
Do you have a QR code?
I don't, but
QR code.
it's a good idea. Yeah.
You guys have an interest in interesting technology perspectives? We're going to be here tonight.
Yeah. All right, cool. So we're going to go ahead and get started. I think this is it pretty much. Okay, so everyone, welcome again to Golden Beer. So I'll just go ahead through the agenda for upcoming events. So today we're having Vince talk about async and await. Their .NET 4.5 features, right, for the C# programming language. Next month, August 14th, Kevin Mack is going to be talking to us about BIM. I don't have much information about it. What is it?
Block element modifier. It's a way to organize your code.
There you go. Then September, Phil Jordan will be talking about ATDD. So he's going to have a different approach from your traditional ATDD presentation. Should be exciting. In October, we have a very special event. It's Pecha Kucha Night. We have 10 speakers. 6 spots are left. And traditionally, I believe it's a presentation up to 7 minutes long or so, shorter than a lightning talk.
20 slides, 20 seconds each.
Yeah, 20 slides, 20 seconds each. So for more information, go to the pechakucha.org website, and you can actually see demos on that. Tonight, we're actually going to show one of those so you guys can get an idea of what Pechakucha is. It's about a 7-minute presentation. Then November 13th, John Fairchild will be talking about client-side framework juxtaposition. I'm not sure about the details, so.
What he told me is he's just basically comparing different client-side frameworks, compare and contrast when to choose which framework.
That's very cool. And then I have a headshot on the Yammer portal, so I had to go to a Facebook profile and steal one. So just a warning to all of you guys. In fact, if you looked carefully, that's not Matt Yeager.
Really, you can't even tell.
Who is that?
It's one of the.
Oh, is that Miami Vice?
Yeah, Miami Vice.
All right. Dig it.
So it's just a warning to everyone. Okay. Too bad he's not here to see it. And then we have no meeting in December, but if you guys can persuade us into having one, we're more than open to talking about it. So we have 4 organizers, just in case you guys didn't know. It's myself, Wes, Nick, Martin, and Kevin Mack, who recently joined us. So I'll talk to any one of them in case you guys are interested in presenting. Like I know Caitlin wants to talk about designing with crap sometime. So.
Did you get chosen to speak at the Arena Tech Night? Wasn't that one of the topics? Oh, okay. So we definitely want to hear it.
Yeah, we definitely want to hear it. Yeah. So you're scheduled for January. So that's it. Thank you, everyone. So without further ado, actually, do we want to do the Pechakucha demo right now?
You want to do it now, or
Let's give him enough time, make
All
sure
right.
we get through.
Okay.
It's already 5:17.
Cool. Thank you, everyone.
is that design with? Is that a Star Trek? Yeah. Okay. Before you get started, yeah, I haven't seen that. You're still set up good, but as far as I can tell, this infinite loop between us will work.
You have an infinite loop going?
Yeah, because the video of your screen of my broadcast. Thinking about that one.
I am the king of infinite loops. Does that stop the?
Yep, we're good. And your
Okay.
mic's on there too.
I have no mic here, but wherever the mic is.
You're welcome to stay.
Ah, yes. Be right back. Okay, end-to-end async and await. And the slides are working. Cool. So, what is it? Why is this relevant and important? How does it work? And if we were to put this on a timeline, that's a significant portion. A few gotchas and some rules to follow. Best practices and details, getting into the nitty-gritty stuff. And then some other information you can look at. So, what is async? Came out with C# 5.0 and in the .NET framework in 4.5. Built-in async and await keywords. And the idea kind of is making this available to the masses, making asynchronous programming available to people who otherwise are, afraid of threading and more deep runtime kind of stuff. Let's see. A few questions for you. Do you think when I say asynchronous programming, does that mean parallel programming? You're a consultant there.
Highly paid.
So it could be, but not necessarily. Does asynchronous necessarily mean multi-threaded programming? Same thing. It could, but not necessarily. And you're detecting a theme here. Do you think asynchronous is easy?
Yeah.
Yeah, no problem. No.
You will at the end of this talk, right?
No, not necessarily. I wish with async and await, it kind of goes like if you look on the web and Google it and see some examples, like, oh wow, that's really easy. Well, then when you get into the real world and you want to mix things together and you get it all jumbled up and do multiple things together and coordinate them and blah blah blah, it gets to be messy. And you'll see all the guts and glory here. So why is this relevant? Why, first of all, why did Microsoft bother doing this? Because this was a heck of a lot of work for them. Who can name for me the new language features introduced with C# 5.0? And we know what one is. Anyone know the other? Because there's only two.
Lambda?
No, that goes further back. So there was async and await, and then the other was in
Windows 8 apps?
some debug information about who the calling method was. Something like that. I can't even remember it off the top of my head. In other words, it was like this complete minutia, and then async and await. In other words, this was really, really serious work for the C# team just to put this together. So why did they go to all that trouble? Well, there's a couple things. One, they've been trying to get this right for multiple iterations of C#, going all the way back to ASP.NET 2.0 and very early versions. And we'll see a little bit of that history. So they've been trying to get it right. They also, this came out in the time frame around Windows 8 and Windows 8 apps, so WinRT and all that great stuff. And they wanted to make sure that even on a lowly ARM processor, slow processor, that these UIs would be very responsive and nothing would slow down the UI. So this was to make it easy for, in part, to make it easy for people to write responsive WinRT apps, Windows 8 apps. Okay, and the other goal, to make this simpler, which is kind of that thing they've been striving for years. More approachable for the masses. But if we're going to say more approachable, then what are you comparing this to? So let's rewind a bit, look back. Now the much older ways, going back to the .NET 1 and 1.1, you spawn a thread, you give it something to do, and then you loop. And you wait for the thing to be done, and then you build the thread. And now, so not that old, which I did plenty of that. APM and EAP, of course. APM, asynchronous programming model, we'll see what that looks like. We're not going to dwell on this, just kind of flip through it. And then the event-based asynchronous pattern. So we'll see there are prior attempts, and then why that kind of drives us to something easier. This is APM, kind of goes like this. We said we're going to begin some asynchronous task. It's going to give us an async result. We can loop and wait until that's done. Sounds kind of like the old school method right there, but it's fancier. And then finally, when it's done, you can say end and give me my real result. So you say begin, and you get kind of an intermediate result, and then at the end, you get the final result. Now that, you could just skip the whole looping thing and call the end right away, and what do you think would happen if you did that?
Blocks until complete.
It would block the thread until complete. Ah, there you go. So that,
read the comments.
so that's one way to do this, but so let's think about this. This is a simple example. We're doing one task, and it looks fairly straightforward and pretty linear. Linear is a good thing. So no complicated code constructs here. But let's scale this up a bit. What if you wanted to do this with, say, 2 or 3 or 4 tasks that you wanted to spawn off, and then when they're all done, continue, and that's not an uncommon scenario when you get into asynchronous stuff. So you'd have to begin the 3, 4, 5 tasks, whatever those are. You'd have to loop through checking every single one of them to see if they're done. And what if it's an indeterminate number of things? You can see how it gets much more complicated. You would have to coordinate and manage all these threads and all this stuff going on. So this doesn't scale real well when you get to slightly more complicated scenarios. Again, don't want to dwell here. Here's the next one. Event-based asynchronous pattern looks like this. Just real quick, so we can new up a class that's compatible with this pattern. And then we're using events. So I'm going to fire you off. Let me know when you're done, basically the theme. And then when it's done, you can continue on with whatever else. And then you say play or go or do your thing or whatever. And then when it's done, fires the event. And then you're off doing whatever's next. So this is not linear, right? Because this code is going to step through linearly, but then that's going to fire whenever. So same theme as the last one. How does this work if you have multiple things you want to do? You're going to fire off these, and different events are going to fire, and then somewhere in your code you're going to have to say, did all those things complete? If they did, then we can go on. And so this is actually even worse to coordinate multiple things going on. And again, doesn't really scale real well. It's relatively easy for one thing, but so these are the old ways of doing things. In .NET 4.0, wait, no, 4.0, they were supplanted by the TPL, which is Task Parallel Library. This is a thing of beauty, no doubt. Really, really nice stuff. And when this came out, they immediately said, don't use those guys. So if you go look up the documentation on TPL, first thing, don't do this anymore, because it's much better with Task Parallel Library. Looks like this. Now that's a lot of stuff. I want to zoom in. Basically covers a lot of languages. It's a comprehensive kind of parallel and task-based framework. Let's zoom in on the right-hand side and focus on some things like there is a task parallel library, so parallel constructs, tasks, and task scheduling. So tasks are huge. Oh my gosh, something must have let out. Right shirts. Concurrent collections, so that if you're doing multi-threaded stuff and you want to store stuff in a collection, you want to make sure that it's thread safe. So these concurrent collections are great, all automatic. You don't have to manage the thread safety and all that good stuff. Parallel LINQ queries, everybody loves LINQ. And you can query collections safely with parallel LINQ. So there's just a quick example. So like parallel for each. You want to do these things, process a list of things, but do it completely in parallel. Don't care how many, just do this in parallel. That's pretty cool. That would take a lot of work in any of the prior ones you saw before. A parallel invoke, so kind of similar. I want to do these different tasks. So the first one was do this to a list of things. This one is do a list of things. Here's a simple task example. So new up a task, give it something to do, and then start it. And if you want, at the end, you can wait for it to complete. And wait is, again, that blocking, that will block the thread. But pretty straightforward. And in fact, these are still used quite a bit in the new hotness. So they have to have their 3-letter acronyms. Task-based asynchronous pattern. That is async and await. This doesn't exactly replace the task parallel library. It builds on it. So it is simpler than those. But again, like I said, it builds on the task parallel library. So you'll still see tasks all the time as we go through all the examples with async and await. So here's the first real example, and in fact, you're going to see this multiple times as we go through this. It's kind of like peeling the onion. We'll talk about it at a high level and then just dig a little bit deeper each time. So what you see right off the bat, highlight these two. You see async and await, and they go together. If you're going to await down here, you need to mark it with async up there. We'll get into the details. Then you see the await. I'm going to await this get string async. Now when you do that, that's going to fire off an asynchronous task. It means it's not going to do that immediately. It's going to say, I want to do this asynchronously, so go start this thing, and in the meantime, just return a task back. Just immediately exit out of this function and return a task to the caller. And then this other stuff at the bottom, that comes next, but not now. So as soon as you get to that part and you say get string async, the function immediately returns. If you were to walk through this in a debugger and step to the first line, step to the second, and step, it would immediately go out to the calling function. You would not hit this subsequent code. It's weird, but that's exactly how it behaves. Step, step, out. Get the idea? I know, it's weird, but that is how it works. And then when that is done and it returns, then it executes the remaining code. Again, that's high level. We'll go deeper and deeper. Okay, so how does this work? If you were to go Google this and go to like the main Microsoft page for this, this is what you would see. So let's take some nice time and walk through this thing, all right? So you start at number 1, and you do that thing, and then you go down to number 2, and then to number 3. You with me?
No.
No. This is punishing. I stare at this thing like, this is ridiculous. Who can read this?
Is that actually on their documentation?
Well, that's the real thing, yeah.
No, that could be fake.
Yeah, that too. Okay, let's go back to this one, and we'll peel a layer and go a little bit deeper. So let's highlight things. Hope nobody's colorblind out there. So here's how this breaks down. That async up there, nothing more than compiler instruction. You got to have it in your code, but nothing more than that. It doesn't do anything except for at compile time. Tell the compiler, I'm going to do some async stuff down here. Next, you have code that fires nice and linearly right before the async code. So that's the normal code. Then you have the async code. So this is going to await a task. And we already said when this line fires, what happens? Where does it go?
It's back up.
It goes out. It returns from this function a task.
Does it return a task with like the type int not declared yet? That hasn't executed?
It returns a task.
Okay.
The int inside that is merely saying, when I actually do return you a value, it will be
Okay.
int.
Okay.
So that's weird. Yeah. And then finally, there's that green code that executes once the asynchronous task is done. So it gets down to the await, returns out and does its thing asynchronously. And then when that's done, comes back in, the runtime drops you right back where you were on the exact same context with the full context stack loaded with your, thread culture, all your thread settings, just like you were when you left that spot in your code. So you can imagine there's actually a good bit of work that happens to coordinate all that. Okay, and then as we get into this a little bit later, you'll see that we'll change things around a bit. So we're going to soon refer to the await code as the awaitable, and the code that follows as the continuation. Okay, so a little bit deeper. The actual code. So let's take a look at this. This was like most of Kevin Booth's presentation at Dog Food last year, staring at this code. Oh yeah, that fits just fine. That's better, you can see that. Okay, let's start at the top. So internally, when you write a line of code that says await this thing, and if you recall, ours was await, it's string something, what was it? Oh, download HTML async. Okay, so it internally, the compiler, that's what we called it. The compiler internally generates a state machine to execute that asynchronous code. So it's going to call this method here, which is going to set up exactly what it needs to return whatever your result is back and make it run asynchronously. And it is going to build this task method builder and then start that asynchronous task. And there's where it returns that task. We said it immediately returns out, so it starts that other task here and then immediately returns back the task that needs to be executed asynchronously. And the runtime takes care of coordinating all this stuff. Now what it's actually doing when it says start that, here's the actual state machine. Not going to go into this in detail here, let's get crazy. But basically the main moving part here is this move next. So just move through the state machine. Start here, next step, And it really, it's not a complicated state machine, but so initially it'll come through, drop through, check to see, okay, there's my, does that look familiar? That was like the line before the async task. So that's the before await. And then calls there's the async function. Remember we said it's an awaitable. So there's getting the awaitable. And right off the bat it checks, okay, was this like an instantaneous task and we really didn't need to do all this async stuff? Because if it finishes immediately, then don't bother spawning off maybe another thread or whatever else to get it done. So it could just immediately complete and return. Otherwise, it'll keep on and moving that state machine through. Again, I'm not going into details on all this, but the point I want to make really is there's a whole lot of stuff there. All we did was await client.getString. We just did one little line of code, and they generated all that stuff. So you can see what will happen if you're putting async all over the place. There's a lot of stuff happening behind the scenes. And this does have an effect if you kind of overdo it, which we'll talk about later on. So every time they're generating that whole boilerplate state machine code, then we're stepping towards another couple of details. There is what's called a synchronization content. Remember I said there's a lot of coordination to make sure when it spawns off that task, and then it comes back to continue the rest of that code, the continuation. There's a lot of coordination to make sure that we return back to the exact same state where we were before. And a synchronization context manages that. And the other topic is continuation tasks. We're going to talk about that bottom part that executes after async. That's the continuation. So continuation tasks, pretty straightforward actually. So a synchronization context. This is what helps restore the state of the thread and everything when you get back to execute the remaining code. So this is basically, there's an older version of this, a little more specific. This is a more generalized version of that. Basically, it's a way to queue up work. So you can say on it, I want to do this, this, and this, and give it to a synchronization context. It'll throw that to the runtime, and the runtime just figures out how to manage that. And you can read some posts about that, and it's pretty gory stuff. Very, very deep. And it changes over subtly or majorly between point releases of the .NET framework, the runtime. So it doesn't specify a thread, but it gives the context everything it needs to restore back to any given thread. And like I said already, it keeps kind of a queue of work that needs to be done. Okay, and every thread has one, and it is actually possible but unusual to throw it, between threads. Okay, so there are multiple versions of this. So for Windows Forms app, for WPF or Silverlight app, Windows RT apps, ASP.NET, and then the default, like for a console app or something like that. So for example, Windows Forms, there are as many threads as there are allocated to the UI. Each one has its own synchronization context. And WPF and Silverlight, as I understand it, there's an independent dispatcher thread, and they execute there. WinRT, I think, behaves like Windows. ASP.NET is the weirdest of all. If you're familiar with that and how the ASP.NET has its own thread pool allocated, and the threads each thread walks through the ASP.NET lifecycle of events. And as it goes through that lifecycle, it could start on this thread for this part, and then as this goes to the next step, could get a different thread. Weird. But that's how they keep IS running really fast. And then the default just runs off of the raw thread pool. So many different versions of that. As a developer, using async and wait, we really don't care. Okay, then those continuation tasks. Like I said, this is actually pretty straightforward. That's how .NET executes that remaining code after the async call. And it looks like this. And like I said, it's not that bad. So we have a task, and we're just telling the task, when you're done, continue with this other work. And that's it. So when you start it and it does its thing and it completes, then it goes and runs that remainder code. So no rocket science really there. But that's what it's called under the hood. Hanging with me okay so far? Okay. So let's walk through this again. Again, async, just for the compiler. There's the code that happens before, and you saw how it actually made that call when it generated the boilerplate code. There's our await, which immediately returns out. And then the post-await code, and again we said that's the awaitable and the continuation. So that generates all that extra code, and then when it's done, there's that task.continue with, and that code finally executes. Now, I will be asking you questions like, how would this code execute later on? So you will be tested on this. All right, some simple gotchas, kind of some limitations of this. So, for example, you must say async if you're going to call await. So there's kind of a weird, there's one exception that's void events. So like if a button click or something. Even those guys, you would take that void and you would say just async task. Like Chris, you called out earlier that one that was task int. So that meant the function actually returned an int. Well, this one's returning void, nothing. So in that case, you just say replace void with async task. That's good enough. Because it does still, when you call await, it does return a task there.
It's the task that contains the return object.
The task will have in it, yeah, the return value.
Okay.
Yeah. With async, you can't return ref or out. Those, with ref and out, you're expecting those values to come back into your variables immediately, and they're not gonna. So they just something they just couldn't handle from the I don't know, the code they generate around this. And there are others I'll go over too. There are some times, like when you cannot use async and await. For example, in catch and finally lots. So let's think about this. What is something that you normally do when you catch an exception? What do you usually do with that exception information?
You ignore empty cat blocks.
You just consume it, right? I heard it. What do? You write it to a log. Okay. So you would typically write it where? File system. Okay.
Azure, maybe like remote storage.
Remote storage, database, whatever. Are those immediate, determinate length of time kind of operations, so you know it's going to come back in 1 microsecond, always, every time? Of course not. It's going to take some indeterminate amount of time. And if you were to look at the standards document from Microsoft about this, they would say that any event that takes longer than 50 microseconds must be async. That's for like the WinRT app requirements. So can you guarantee those are going to finish in less than 50 microseconds? Probably not. So those are things you would want to await, but you can't, because it's a catch block. So what do you think you could do to solve that? You can't await, but you're calling operations that are async. This has been solved.
Like, would you emulate async, so you would do like a thread and go back to old school?
We'll discuss that later on. No. Basically, the simple solution is you would write it somewhere in memory, like store temporarily. I'm going to write you out, but not yet. So you would log it to something immediate, like, I don't know, whatever sort of structure. And then after you're out into some place where you can do async stuff, after the finally, then you would flush whatever those messages were, and then they would be written to wherever. Now this one here, Microsoft has already said they finally figured it out. They figured out how to do this, and so in the next version of C#, whatever 6.0, I don't know what the version is going to be, with Oslo, that version, you will be able to use async and try and catch and finally. Okay, you can't do it inside properties, inside constructors. Just think about it, you'll get it. Inside a lock block. So what's a lock block for?
Thread synchronization.
Locking a thread. And they're like, wait, we're doing the threading stuff. You've got to stay out. In an unsafe region, that's just kind of weird.
Bad neighborhoods around town.
Yeah, that's right. And in a lot of places in LINQ queries, and I'm not even going near that detail. Okay. Oh, some fun stuff. So Chris suggested, let's spawn off our own thread in the middle of all this async stuff. And if you ever start thinking crazy thoughts like that, just remember deadlocks and race conditions.
I'm done here.
Yeah, so you would like to think it's difficult to step into these areas that they, async and await, they spent a lot of time with this. They protected you from these possibilities. So I'm going to show you otherwise. So let's see.
Race conditions aren't bad if you always put it, right?
If you say so. Now let me just go ahead and run this thing. So a simple little Windows format, and I'm going to just deadlock it, which will be pretty obvious. I mean, you can see right now, it's nice and it's responding to my input. As soon as I hit deadlock, it deadlocks. And my CPU is just going. And I can see it's sucking up on my battery too, just like that. And what massive amount, I can't even close it. What massive amount of code did it take to accomplish this daring feat? Right there. 2 lines of code. So what is it about these 2 lines of code that causes a deadlock? So you need to know, what does this delay async do? Well, it doesn't do anything more than just await for 1 second. So it's an artificial delay. But it is awaiting. So it's awaiting that task to complete. It's waiting for something. And you know how race conditions and deadlocks work, right? I'm waiting for you, you're waiting for me, and neither one is finishing because we're waiting on the other.
Yeah.
So this guy's waiting up there, and then what does this guy do? Plain as day, it's waiting. What's it waiting for? It's waiting for the other guy to finish. So you see right off the bat, they're both waiting for stuff to finish. Because this one isn't just waiting for that 1 second. As soon as that 1 second is complete, it's going to say, okay, I need to go back and restore myself to whatever that execution context was. That other context is waiting. It's stuck. It's not safe to continue on that context. So it's very easy. This is like the simplest case example, of course, of causing this. But if you start using some of the fancier stuff with async and await, or you find yourself in one of those cases where you're not supposed to use async and await, and you try to get around it, and you think you got it right, because I did. I stumbled on this umpteen times, where I thought I found a workaround, and it worked for a while, and then, deadlock. I couldn't figure out what the heck. And then sure enough, it was that little workaround I tried to put in place to get around async stuff. And you don't want to do that. Just go with it. So there's your fancy deadlock. It's easy to do. And the fundamental point here is just go with the flow. Don't try to work around it. Okay. Getting a little deeper into some nitty-gritty stuff here. So pretty straightforward. Follow the guidelines of the .NET framework. If you write an async method, name it whatever async. Use this. Well, let's talk about it this way. For example, let's say you're writing a typical kind of application we all do, and we write nice layered applications. So we have our UI layer, we'll have some business objects, we'll have a data layer, we'll have some services, whatever. All these different layers. And you're writing you need your UI to do whatever, so you write some code out to get there, and you end up in your service layer and like, oh, in my service layer, I need to make this database call, or I need to do some I/O or whatever, something asynchronous. Well, that method that you had there now needs to be named whatever async, and it needs to return a task. So now what happens to the code that calls that async method? You're going to have to say, await this new async method. But that method, previously, that calling method wasn't originally an async method. But since you're calling this new async method, you got to make that one async. So you got to rename that method, and cascade that rename, make it await, mark it async, and then what about the function that called that one that used to be synchronous? Now this one becomes asynchronous. You get the idea? So when you get so far down the line and you change something async, you got to walk all the way back and make them all async. So that's what I call the cascading async, and how async stuff becomes end-to-end. Because you got to make all the way through. Everything becomes named async, and that's a bit of a pain. End-to-end also means what I said a minute ago, go with the flow. If you got to call an async method, make your method that calls it, just make it async. Go with it. Don't try to work around it, or you get into those deadlock and race conditions, which of course you want to avoid. Okay, ASP.NET. We do tons of web development, and we're on Gojo. We have plenty of opportunities anyway to use async stuff, and we are in some cases. I've already talked about how ASP.NET is kind of weird in how it handles its event pipeline and how it does its tasking. Pretty darn sophisticated. So a couple of guidelines. This would be on a big content website, maybe a Huntington.com or Nationwide.com, whatever. Lots of requests coming in, lots of threads being allocated. If you have a massive application, you may have to increase your pool's queue limit and maybe increase the async timeout on it. There's some configuration options, but really, you shouldn't have to mess with that. If you're going to be doing web forms, I don't know does anyone still work on web forms here? I don't think so.
SharePoint's all web forms.
Really? Okay. So you might have to deal with some of the lifecycle events like page load and etc. There's some funky stuff you have to do. First of all, in the page, you have to tell the runtime that the page is asynchronous. And then this is really weird. If you want to call an asynchronous method like from one of those lifecycle events, you have to do it like this. So the actual method you want to call, being that get data async, you have to register the async task. You have to do that, which is horrendously ugly. But that's the only way in those events to call async stuff. Which, as we know, all the code that you write in those code lines is tied to one of those lifecycle events. So yeah, that's really weird, but it's true. Okay, unit testing. How do you unit test async methods? First of all, comfortable, you can test async methods, and all you do is you just make the test async. That took me a long time to figure out. Seems really straightforward once you think of it, but you're supposed to be faster. Yeah, I mean, you don't return tasks. The runtime does. But now, that one took me a while, but this one took me a long time. So you want to mock an async method. Yes, you can do it. So there's what you're mocking. And the trick is this guy right here, task.fromResult. So that one took a long time to find. So you can do it. And in fact, you'll see that in the Gojo code. What was that one? The one MVC component, like the user manager or something like that? Yeah. Okay, but yeah, you can do all that stuff. So it's all good. Entity Framework 6. Who's using that? I know we are. Yeah, so real common. You're using 6? Okay. So they've made it very friendly to async. So the DB context, all of its methods have been changed to be async. Queryable extensions, which you use all the time. So, I mean, here's a count, but, you know, first to default, or any, all, pretty much all those functions have async versions of them. Now, they also have synchronous versions. So I guess at some point it's worth asking here, why would you use async over just using the synchronous ones? Is there any advantage? If we're talking about maybe in a web app here, why would you want to use the async version over the synchronous version? Any ideas?
This is what you're doing. Well, if you're going to be blocking for a long amount of time, then you could be doing something else.
Particularly for long-running things, yeah.
Background kind of service where you don't need immediate feedback. A large collection.
So, well, that sounds like another long-running thing. I don't know.
You can take more concurrent requests because you're not blocking a thread waiting for something to finish.
That's the big one. So they've done a ton of work under the hood in the runtime to make sure that they're doing whatever they can to free up threads and make them available. So if you're doing some I/O, maybe you're calling a RESTful service somewhere, and you know that's going to take many nanoseconds to execute. By using async, you're freeing up threads. Makes the thread pool much more efficient. So you can make a much more high throughput app just by doing async for your particularly long running methods. Okay, another example there. Executing tasks in parallel. So you go online and you have to type in how to use async and await, execute in parallel, and it comes up with code that looks very nice, very linear, clean, looks good. Okay. So I have an example here. This is what this looks like. So very simple code. I mean, they obviously did their job well. Yeah, so let's go ahead and execute this one. There's two different ways to do this. This is the first one. So this is almost identical to the code you just saw. Just, you know, await this, await this, await this. And you can see how they're awaited in parallel. So this is going to fire off, and then you'll see each one complete, each task complete. So, okay, number 1, 2, number 3, number 4. Okay, I'm sure that's coincidental. Let's run that again. You would expect them, you know, it's just randomly generating time, and then 1, 2, in order again. Now, can you see the number of milliseconds on those? Which one would you expect to have finished first? The third one, because it's the shortest amount of time. So why is that one third? So it's got to be a fluke. We'll try this one more time. One, 2, 3, and 4. So obviously something's up here. Let's look at this code. There it is, just like you saw. I swear, you Google this, this is what you'll see. You can all see the code, right? So let's look at this. This is your test. On this first one, we say await. What does the runtime do when we say await that? Yeah, you should do that. It immediately returns. And when does it come back to the next line? After that one finishes.
So that's why they're all.
That sounds pretty, you know, step by step. So it's going to finish the first one, come back, finish the second one, come back. That's not in parallel. But it doesn't change what I said before. If you look this up online, you'll see that code, and they'll say, this is parallel. Obviously, it's not. So let's, oh, wait, let me see here. Let's do the right version, which is this one, when all. Look how much faster those finished. And they're out of order, and they're in order of the duration, which makes sense. Run it again. You know, that's clearly parallel. And that's exactly what you want. So what does that code look like? Looks like this. Task.whenAll, and I give it all the things I want to execute in parallel. So that's the right way. Unfortunately, many of you know Scott Hanselman. You Google that, even he did this. I was dumbfounded when I saw that. Disappointed. So he's still does, yeah.
Yeah. Not now.
Yeah, he's open source in ASP.NET left and right.
Question, is anyone actually test their code that they publish? This is a good example.
Yeah, so one is the like official Microsoft blog on how to do parallel things. Like, come on. This is the blog. Wow. Okay, went on. Piece of cake. Oh, this one hurts. Let me show you the example here. And it needs some more windows open. Okay, let me run this first to get an idea of what it's doing. And really, all I'm doing is I'm calling some async stuff, but I'm doing a lot of it. And same kind of thing as before with the deadlock. So I can, this is responding. As soon as I hit call async tasks, however, whoa, I'm dead in the water. So what the heck's going on? Okay, now it's back. So let's look at the code. Now this is the detailed code of what I'm actually doing here. But at a high level, up here, I'm writing a file with random junk. And then down here, I'm just reading the exact same file back. Innocent. Nice, simple little I.O., you know, I.O. bound. That doesn't take threads. But look at the calls. I'm awaiting here. I'm awaiting there. So I'm awaiting when I'm writing. I'm waiting when I'm reading. And I'm doing it how many times? A lot. So up to 10,000 times I'm reading and writing. Remember that whole lot of code we saw earlier? That the boilerplate that it generates for that state machine and all that? It executes that. And second thing, remember that synchronization context? So it's got to take whatever the current thread looks like, write that to the synchronization context, throw that up to the runtime and say, do this whenever you feel like it. And then it restores it to continue execution on that continuation task. So the point is not so much look at how much code there is, just look at how many times I'm awaiting, how many times I'm executing that boilerplate code and synchronization and synchronizing contexts. A lot. So that's the death by 1,000 cuts. And the point behind this is, you know, obviously don't do that. You would want to minimize or somehow organize your code in a way to reduce the number of awaits. So you want to await long-running tasks, not await a billion teeny little tasks. That doesn't make sense. See what I mean? One other thing with this. There's a way to kind of get around this a bit. Let me just change one option. I'm going to uncheck the box. I'm going to call the awaits slightly differently. And when I run it this time, look. Now I still... So just by checking a box, I made the await much faster. And all that did by checking the box was set this Boolean variable right there, configure await. And what that does, so it's a true or false. The first time it was true. And what that does when it configures await, all that's doing is the synchronization context. If I pass false, it doesn't bother with all that. It doesn't bother restoring the original context. So there's no guarantee you're going to end up with the same state that you originally started from.
That's basically disabling the entire await.
Just stopping the synchronization context.
Okay.
So think like the call stack.
Yeah.
It'll still push the task to the synchronization context, which says, here, run this, but it doesn't restore it when you come back.
Yeah, gotcha.
So that context switching is an expensive operation. And here's the proof. You can see how big of a difference it made. Now, the question then becomes, why would you bother storing the synchronization context? And more importantly, why would you bother restoring it? It's so intensive. Any of you ever done multi-threaded programming on a UI app? You always have to make sure if you're going to change, let's say I need to change a button's text, or I need to write something to a text box. You better be on the UI thread when you try to write to those controls. And if you're not, it'll blow up and tell you, sorry, you got to do it this other way. You have to be on the UI thread. So in a UI app, as one example, you want to make sure you've restored your context back to that UI thread. If you haven't, it's going to blow up. This one here is a simple old app where I'm not writing anything back to the UI when I come back. I'm writing a file, but I'm not doing any sort of UI manipulation whatsoever. Don't need to restore that content. So, again, we're in the nitty-gritty details here, so keep that in mind. It's actually a good thing to say, await my task dot configure await false. It's okay to pass false if you know you don't need to come back on the exact same thread or with the same context. Okay, so there's avoid making too many calls, backs them up, do big things with async. And there's configure await false. That's one of those you need to read the details. Okay, this is getting really far out there. If you want to make a method asynchronous, and that method inherently is synchronous, there's no async calls to make, but maybe it's a long-running thing, and you just want to make it asynchronous. You can do that. Just say task.yield. That'll instantly force the runtime to treat it like an async method. And it will behave, it will run it as a task and all that good stuff. And then a couple other things, you can cancel tasks. So if you truly have one of those long-running tasks and you say, await this task, you can coordinate with it and tell the task, oh, cancel yourself, I'm done. Now, of course, in that task, you're going to have to be polling for that cancellation. And then if the cancellation comes through, you pass a cancellation token. If the token becomes true that you're canceled, then you have to return back in order to honor the cancellation. So there's some coordination there, but you can do it. And very, very similarly, you can also report progress of an asynchronous task. So if you have a significant long-running task and you want to show a progress bar or whatever, again, you have to pass through a token and report back periodic status. You can do it. Supports it. Okay, that's about it. So next steps are simply that there's plenty of stuff to read out there if you want. And again, this was like the one core feature of C# 5.0. This is a big one. And it's becoming more, if you look at the framework, you'll see those async functions all over the place. It's kind of becoming unavoidable. So you will have to be using this at some point. Okay, that's about it. Any other questions? Time for your video then?
Sure, that'll be.
How do do they have good like debugging support like for debugging asynchronous events?
Good question, because when it first came out in Visual Studio 2012,
Yeah.
when you would, let's see, it was when you were in a method debugging and there had been an async call somewhere along the line, you would lose that portion of the stack. And so you'd see your stack call, and it would not accurately represent the true call stack. And then in Visual Studio, it might have been in an update to 2012, or it might have been 2013, I don't remember. But they have since fixed that.
And do you know like in JavaScript they have like promises? They have something like promises and C#. I saw something like when all. That's kind of similar to it. But like there's not really like call.
Could you think of the continuation as a promise?
Or behave something similar. Yeah, something like that. Where you could say like dot cast, and you could say like when it's dot done, dot fail, and stuff like that. Kind of daisy chain asynchronous tasks.
Right.
I think
Yeah,
that's
there's,
the continuation.
that's one way to get at it.
One
But
way like it. Okay.
I mean, you get that. That requires nothing more than delegates
Okay. Yeah.
to accomplish that. You know. What's that? And again, it's nothing more than
Yeah.
delegates.
Delegate,
Yeah.
yeah.
And it does. I mean, promise is one scenario. There's umpteen scenarios where you can do that.
Does Java have asynchronous model? I don't know yet.
I don't know.
Okay.
And I know they are changing this with C# 6.0 or whatever the next version is, but I don't know any more details than I already mentioned earlier. So, who wants to plug back in? I don't know what the next version is.